Hello, everyone. Thank you for joining us today for our live webinar for CEF Context Broker. My name is Erbil Kop, and I'm the onboarding manager for Context Broker at CEF SMO. And it is my pleasure to welcome you today, where we will be speaking about the extended support projects that we've been working with for the Context Broker, and also Adam Milton-Barker from one of the latest onboarding success stories that we just recently published. So without further ado, I would like to just remind our audience that this is an interactive session, and you can see on the right-hand side of your screen a Q&A box where you can direct all your questions to our speakers. Please keep your identity anonymous while posting. It will allow us to quickly show your questions during the presentations or the dedicated Q&A session in an anonymous way. This is for GDPR and IDPR compliancy. And I would like to also remind our audience that this webinar is being recorded. A quick look at today's agenda. I will be sharing the honor of presenting the Context Broker quickly and some of our highlights with the help of my colleagues Regina and Caroline Corneau, followed by the intervention of Adam Milton-Barker, and apologies in advance for our Spanish audience for butchering the name of the association, Asociación de Investigación en Inteligencia Artificial para la Leucemia Peter Moss, which will be followed by in-depth presentation of the 3 extended support implementation journeys, and we will close our session with a Q&A, dedicated Q&A session. So without further ado, I would like to remind everyone what we've been trying to achieve with CEF Digital and our active in various activities throughout this whole session. Our basic mission was to increase the interconnection between trans-European networks and help, in order to do so, helping the public administrations and businesses and citizens to fully benefit from the digital life has to offer. And we've been trying to help the digital transformation journeys by the usage of what we call in-house building blocks. And regularly we prepared a lot of trainings or webinars as this one in order to reach out and get people accustomed with the systems that we were using. And we onboarded them, as we call it, in-house to help them implement our building blocks. This is a quick overview of the 10 building blocks that CEF has to offer. I will not go into much details, but today's main highlight is the Context Broker. So what is the Context Broker? In really a quick nutshell, it's a system that allows you and your organization and your digital solution to be able to gather data coming from multiple sources and use this data in real time in your implementation. And the most added value of this is that it's an easy way of developing this into your existing solutions. And it is not, to quote our dear head of the technical support team, Stefano De Pamphilis, who's not with us today, it's a system that allows to not break the silos, but to join the silos, to allow them to work together in a harmonious way and in real time. And it also enables the creation of digital single market of data marketplace. This is really the basics of it. And as I've said previously, through our actions, we've been able to, and this is only the numbers and facts known to us, because since it's I'm sorry, I'm lacking words. Since a standard-based European solution, it's completely open source and it's free. And we do allow our users or interestees to use this even without us knowing. But in our radar, we have a total of 21 reuse of Context Broker. And with the different various reaching out actions that we've been able to do in the past year, we had 247 participants up until today, and we are expecting a lot more, and to see what the future brings. So this was really quickly speaking about what the Context Broker is. I will quickly now have the pleasure of adding Caroline Corneau, and Regina Della Eva, because I'm the lucky one of saying I'm the onboarding manager and I'm the public face of this, but it's everything that we've been able to achieve through our regular ways of doing is, of course, thanks to a huge team working with us, and Caroline and Regina are the main helpers or guidance that we might have along the project. So I don't know if either Regina, who will be speaking thoroughly at the second part of the presentation, would like to say a couple of words, or Caroline, would you like to add something?
Yes, hello. Just to say hello, and I hope you can hear me well. First of all, thank you all for being here today. And indeed, I won't be speaking much, just to give as much time as possible to what we are here for, to listen about our latest projects with the
As I was fearing, Caroline's connection is
CEF.
lost.
It's a good thing to be. Can you still hear me? I shut down the camera. I don't know if it
No,
helps.
it's just fine. It's just currently it's just fine.
Not really. Okay. Well, okay, but I just want to say really thank you to everybody that we've been working with in the FIWARE Foundation, of course, in the different development teams, to Regina and Erbil also specifically, and then to everyone really already using the Context Broker, and I hope many more in the future. So I hope you heard me fine. I'll leave it at that for the moment. Thank you.
That's just perfect. Thank you.
For myself, I have nothing to add, as you'll be hearing me speak later. So
Yes.
I can just have my speech a bit later. Thanks.
All right. All right. Thank you very much. So without further ado, it is my great pleasure to welcome now on screen Adam Milton-Barker, who's, as I've said previously, is the latest onboarding project that we had in our regular ways of doing. And Adam, the floor is all yours.
Thank you for the introduction, Erbil. I'll just load my slides. Are you able to see the slides? Yeah. Okay. Okay, so my name is Adam Milton-Barker. I'm the president of the English translation is Peter Moss Leukemia AI Research Association. And I'm going to be talking today about our implementation of the Context Broker, which is highest CDI, which is the highest contextual data interface. So a little bit of history about our association. In 2018, my grandfather, Peter Moss, was diagnosed with acute myeloid leukemia after an all-clear blood test, which was 1 month before. His prognosis at that time was only a few weeks to live, and I was convinced that there must have been some sort of signs in his in the blood test that he had the month before that could have possibly given some notice that my grandfather had this disease. 1 month after that blood test, he collapsed, and they gave him a few weeks to live. I had experience with using artificial intelligence for breast cancer before. Just to be clear, I'm not a medical expert. I don't have a medical experience other than what I'm learning through the association. But I did have experience with building a classifier for breast cancer detection, which did quite well. So I wanted to try and do something for acute myeloid leukemia. My grandfather actually survived for 1 year. 1 day short of 1 year from his diagnosis in 2019. And once I got the blessing of my family in 2020, we registered as a non-profit association to continue the work that we've been doing since 2018. We open source everything that we do, and we don't charge for anything. Everything is available through GitHub. Our long-term goal is to hopefully one day play a part in early detection of leukemia using artificial intelligence, and also to automate the medical industry using the latest technologies. So highest CDI is the highest contextual data interface. Highest is a platform that we've been building. Again, it's open source, which utilizes many different types of technologies with the goals of automating and making medical organisations and hospitals more efficient. Again, just to be clear on this, we're a very young association. We are making a lot of progress, but we're not in the situation yet where our technologies are being used in real world use cases, but we are working towards that. So the highest CDI is a Python implementation of an NGSI v2 context broker, and it basically holds all of the contextual data from the highest network devices. So the highest network is made up of a core server, and through modular devices that we publish and open source on our GitHub, you're able to build up a network of intelligent devices. These devices could include classifiers for leukemia, classifiers for COVID, natural language understanding, facial recognition, and other modern technologies. And they're all designed to work on low-powered devices such as Raspberry Pis, Arduinos, and devices like that. So these devices together make up this network, and they all publish data that ultimately ends up in the highest CDI contextual data interface. We use IoT agents, which are based on FireWare's IoT agents, and they are protocol specific. One of the main machine-to-machine communication protocols that we use is MQTT, which is one of the most popular in the world of IoT. And that device basically sits waiting for data and information that comes from these devices on the network. It does some verifications through a blockchain. It makes sure that the device has permissions, and using smart contracts, it makes sure that the device has permissions to actually store data into the contextual data interface, into the broker. And it also stores an immutable hash of it so that we can use that for data integrity. So the context broker holds not only the contextual data that's coming from the sensors and the artificial intelligence models that make up the network, but it also holds all of the configuration for all of the devices, all of the applications, and all of the users that are on the network. So the broker has really become one of the very core features of the whole network. In that way, it powers the highest network. As I mentioned earlier, we use IoT agents. There's a spelling mistake there, sorry, it should say bridge. And again, they bridge the devices that are connected to the network to the highest contextual data interface. So just to finish up, I mentioned we are a non-profit. We're completely unfunded, and we rely on the help from our volunteers. We are looking for new volunteers to join with us. Again, we are young, but we are an innovative non-profit association, and our long-term goal is to battle leukemia with open information and open technology. So if there's anybody that's watching today that would be interested in joining as a volunteer, we're looking for people that can help us with marketing, social media experts that can translate our language into something that's easily understandable for social media. We're also looking for deep learning engineers and some additional medical advisors to join with us. We currently have 2 medical advisors at the moment. One is a doctor in haematology, and one is studying Bachelor of Medicine and Bachelor of Surgery. And we're also looking for technical, medical, and carer writers. One of the platforms that we're building is the Leukemia User-Driven Healthcare Platform, and the first stage of that is a support network for patients, caregivers, and medical experts. So if anybody would be interested in joining with us as a volunteer, we'd be more than happy to hear from you. And you can see the link to the application, and I think Erbil's going to share that in the chat for you as well. So that concludes my talk today. Thank you very much for everybody that's supported us from CEF, from Fireware. It's been a really great experience for us, and we're looking forward to the future of our collaborations. Thank you.
Thank you very much, Adam, for this touching and very insightful presentation. As you said, I took the liberty of copying for our audience the link in the chat. And I do also see that there are questions that are coming, but I suggest that we go along with the program and then address them at the Q&A section at the very end. So without further ado, now it is my pleasure to announce and add Regina to the fold. So Adam spoke to you about our normal ways of, let's say, to onboard projects and help them, assist them to make their story a success. But we realized that we can always do more, and Regina and her team will be presenting now the extended support projects that we've been undertaking. So without further ado, Regina, you are on screen, currently muted, just so you know. So I will leave the floor to you. Now it's perfect. You can go ahead.
Okay, yeah, okay. Thanks, Erbil. So yeah, as Erbil said, my name is Regina de la Eva. I'm a Context Broker project coordinator. So I'm here along with my colleagues Sancho Canela and the representatives from the cities of Ourense, Sevilla, and Benidorm to present to you an implementation journey of 3 real case implementations of the Context Broker. So the goal here is to provide some inspiration on how other projects can implement their own. So we're going to present here how the 3 systems were created for 3 different objectives. So we'll talk a bit about the context of the different problems, the technical solution identified, what was developed. We'll show you the results, and finally share some key conclusions and recommendations. So on to the more interesting part. So here I present briefly the background and context for each implemented project. So later, of course, each CD representative will also speak to give a bit of their input on their experience with the projects. So to keep in mind, each project was implemented on a specific scope, and there's always the view to expand this scope further. So for the case of Ourense, so as we all know from news, before COVID, forest fires are a powerful destructive force in our planet, and it's currently claiming millions of hectares of forest each year internationally. So one of the hardest hit by forest fires is the province of Ourense in Spain. To combat this, the city of Ourense has identified a need to be able to better detect wild or intentional fires early or even before they start in order to take action and prevent spreading. So what was found is that there was a system that was needed to be created to be able to collect real-time data from the forest and provide context to this and be able to better interpret and analyze this data. So real-time data here would allow the administration to conduct instant analysis of this information and be able to provide the forest agents with what they need to make accurate, timely decisions and act accordingly. So to accomplish this, later on, this will be the systems that will be presented. So for now, we go to the city of Sevilla. So Sevilla is known to be a historical city with a diverse collection of cultural assets and heritage. So the city of Sevilla would like, of course, to ensure that future generations will still be able to appreciate their heritage and, of course, enjoy these assets. So the city is now aiming to preserve its historical and cultural heritage by protecting its most valuable historical assets. So among one of them is this Baroque church complex called the San Luis de los Franceses. Sorry for my terrible Spanish. The complex is, of course, of extraordinary artistic quality and historical relevance for Sevilla. So this church, after years of renovation, was open to the public and is currently a museum space. So to aid Sevilla in these goals, a system was created based on Context Broker that will allow the city to effectively monitor real-time data and create valuable historical information from key conservation elements of historical buildings. So that we can minimize the damage and deterioration of the building and artifacts that are contained within. So the last use case that we have is the Benidorm. So this is a topic that's something we've all been trying to do for more than a year now, is to go on vacation somewhere warm and sunny. So Spain, of course, as we all know, tops the list as one of the most visited countries in the world. So tourism is one of the most important sectors in Spain. Benidorm, a coastal city in the east of Spain, is among the top 12 most visited Spanish cities each summer. So Benidorm aims to provide its visitors and residents with the best possible experience while enjoying the available outdoor activities in the city. So the goal here is for city officials to be able to analyze real-time data and information to improve both the quality and management of the activities that promote health and well-being to visitors and residents. So to accomplish this, we of course also have another context broker-based system that was developed to provide real-time monitoring of environmental conditions related to such popular activities such as biking, walking, going to the beach. So to continue with the presentation and give a bit more of the perspective from the cities themselves, let me call on my colleague Sancho Canela to introduce them.
Hello, everybody. Thank you, Regina, for this wonderful introduction and this excellent presentation of the Context Broker. And thanks to the 3 cities that have made these 3 projects possible. Without them and without their support, we could not have these success projects. I will give the floor now to the city officials to explain in some words what the project means for them. First of all, I wanted to introduce Carmen, Managing Director from Impro. So, Carmen, the floor is yours.
Thank you, Sancho. Good afternoon, everyone. My name is Carmen Rodríguez, and I am the Managing Director of Impro of Diputación of Seville. And from Impro, we provide IT service for the benefit of the local entities of the province of Seville. Together with Everest, we have designed a project focused on the use of Context Broker as a base platform for monitoring key aspects of conservation of historical heritage. The Church of San Luis de los Franceses, an 18th century building, was the setting chosen to design and deploy this project. We hope that this project will be useful to use to carry out preventive conservation of the property, allowing us to measure aspects such as the amount of lighting, humidity, temperature, or CO2 levels. In this way, we will be able to make the appropriate decision regarding the conservation of our heritage, unique in the world. Our goal is to extend the project in the future to other municipal assets, and we hope that other public bodies throughout Europe can reuse what we have built to improve the conservation of our historic building and our artistic heritage in general. Thank you very much, and thank you, Sancho.
Thank you very much, Carmen. Now I want to introduce Fernando, Director of the Transparency and Open Government Area of Diputación de Ourense. Fernando, the floor is yours.
Okay, good afternoon to everyone. Thank you, Sancho. Thank you to all of the audience. In the case of Ourense, the fire problem has been changing, meaning over the last 2 decades. Today, fire is widely spoken of a global problem. And the fire problem is a development problem, and therefore it appears with more intensity in developed countries. A paradigmatic example could be in Galicia, in Spain, where Ourense is located, where there has been an upward trend in the number of fires in the last 20 years or so. So from the point of view of an administration like Diputación de Ourense, developing programs and plans to fight fire at 2 levels, prevention and extinction. Actions within prevention would be all those aimed at environmental education work for the different target groups that inhabit the area. In extinction, all activities aimed at suffocating and minimizing damage from fires that have already started coming to play. I think it's important to know that which are the causes of fire in Spain. They are distributed in different percentages. For example, lightning and other fortuitous causes are only 5%, negligence 15%, unknown causes 20%, but intentional are 60% of fires in the forest in Spain. The arsonists carry out the crime with full physical faculties in many cases and seek an end such as revenge, vandalism, entertainment, changes in land use, urban planning, logging interests, or even, although to a lesser extent, protests against restriction in protected area. So I think it's important to know that those responsibility for ecological crimes is a fundamental task. But year after year, despite the arrests, the legislation, the phenomenon continues to appear. So our case, our pilot, consists in a solution to prevent fire forests in the Ourense region. Specifically, this project is located in Cualetro village, where the highest rate of fires in all Europe is suffered. So I think it's the best place to test this case. We want to explore ways to mitigate and solve this serious problem through the use of new technologies like our sensorics, artificial vision, or artificial intelligence, and with the collaboration, of course, of our partner Everest, which is critical for us. So we have several challenges. For example, the connectivity in the forest, being able to gather information valid for taking decisions. We want to be able to monitor what is happening in the forest and gathering real-time information in order to be able to prevent this fire in the forest. So we have sensors. We agreed, we are proceeding with the acquisition. We have deployed them in the forest. So we are excited about this project and the potential benefits that we expect to have. We will have 2 modules, one for monitoring with data like a quality index, fire weather index, and we want to also be able to see in real time a map with the location of the sensor and the information, map with the fire methodological risk levels and the dangerous map. And we'll have another module, which is to prevention of fire forests with alarms and notification models. This model will raise alerts when sensor values have abnormal values, and we also try to detect a smoke presence, early warning, and leader drive vessels presence in underground, preventive action oriented, using those technologies like artificial intelligence and image processing. As we told you, we are exciting. We are beginning the summer, the season with the highest risk for fires. So we hope to succeed and be able to expand this project to the rest of Spain and to the rest of Europe.
Fernando, very helpful. And finally, I would like to give the floor to Aida, Councillor for Innovation in Benidorm. So, Aida, the floor is yours.
Thank you, Sancho. Thank you for Context Broker and Everest to being able to be here. And Benidorm, as a city council from Benidorm, we have a very important challenge to create a sustainable and healthy tourism. Benidorm is the first certified small travel destination of the world. And because this, we are immersed in several initiatives related to smart cities, and we wanted to explore the possibility of using Context Broker as a platform for all sensor control that we plan to deploy in the future. This project will allow us to assess not only Context Broker as a platform, but also the project as a tool for decision making in order to promote healthy tourism. Thank you very much.
So much, Aida. So I will continue now with the presentation. Thank you for this contribution to the three of you. Now we will go to some technical details, let's say. We will explain the architecture, the data model, and the implementation roadmap in this third section. First of all, I will explain the architecture, then the data models, and finally this implementation, remarking at the end what could be reused, because for us it's really important, this point, and I will give you more details later. First of all, the architecture is common to the three projects. Obviously, we have Context Broker as core component of the architecture. Context Broker is the piece that connects with all other components in the architecture, and in the next slides you will see it in a module-based picture. We are using Orion LD version for the three projects that we implemented. As I was saying, you will hear the word reusability and the word open several times during this webinar, because this is one of the main objectives that we had when we were designing the project. We had to build something useful for the cities, but enough open and general to be reused for other cities or other colleges interested in similar business cases. Starting for our three projects, Silvan in Ourense, Minerva in Sevilla, and Nereo in Benidorm, we are using the main components. We are reusing in the three of them the main components and the architecture. In regards to the concept open, we are using this kind of technologies. For the development, we use mainly Python, that it's a light programming code, and it's the most used language for data analytics and artificial intelligence. And we are using as well other open technologies like NiFi and Orion. On the other hand, the context adapters that you can see here on the right of the picture are components that allow the collection of data from open data portals. They obtain the data and include the extractor and the context to ingest directly to Context Broker this data. So we are not taking just data from the sensors deployed that you will see later, but for open data portals and other data, let's say, source that we identify during the analysis phase. Finally, I would like to mention that the Context Broker enable was used as accelerator for the data visualization. This enable provides a visualization layer over the Context Broker. The enable first had to be adapted to conform to the NGSI LD Context Broker for real-time data and Apache NiFi for historical data. This NGSI LD version for the enable was created, and it is available for being reused as well for similar projects in the Connecting Europe repository. Another vision of the architecture is this module-based approach. I will give you some details. As you can see here again, Context Broker is the main module and the core of the architecture. All modules in blue, including the Context Broker, are common to all the projects and are the base for building similar projects. This module has been designed and built with the reusability in mind. For some modules, we could have some customization at configuration level. This is the case of the rule engine. For example, we can have different rules in the different projects, but this difference it's not affecting to the core functionalities of the module that are common to all the developments. We will see more about this rule engine during the demo part. For the 3 projects, several IoT connectors that you can see here on the bottom have been developed in order to get data provided by sensors, by these devices that we are pointing here. These connectors are made for different protocols like HTTP or MQTT and can be reused as well as they are right now, or you can use them as base for building another connectors. As can be seen in the pictures, we have the legend here. Specific modules were developed for each of the projects. This development includes the European Air Quality Index for Minerva, for instance, the smoke detection for Silva, where we develop and train a machine learning algorithm to identify smoke and to be able to differentiate it, for instance, from the clouds, okay, when we are analyzing pictures or videos. Or a mobile application that was done specific for Nereo project. And we will see this application later during the demo part. Now we will have a look to the different data models that we are using. For each of the projects, we have different data models. We would like to remark that the first action we did was a research with the support of Fireware team in order to find data models that we could reuse. Once we identified useful data models, then we knew which ones should be created from zero, because we were not able to find something in the repository or something useful. In this sense, for each of the projects, we have adopted data models that we are reusing 100%, adopted data models that we have to adapt in order to accommodate to the real need of the project and the modification needs already on the Git repository as well, and new data models created for the project that are already on the Git repository as well. So this is the case of Silvan. In this case, we want to remark that we reuse the green space record and the air quality observer as they are right now. For the alerts, and this is common for the 3 projects, we had to modify it, and we have a new field called type of alert that was added, and all these changes were coordinated together with the Fireware team. So this data model is being reused in the 3 projects. A new data model, the file forest status, was also created specifically for this project and published in the Smart Data Model repository. This new data model stored information about the presence of smoke in the forest, the risk index of fire at a given time, and the condition of trees that could increase the risk of fire in a certain area. During the creation of this fire forest status data model, an entirely new category of data models named forestry was created in the Smart Data Models repository. And by doing this, we are creating this new category. We are open more possibilities for projects where data models and Context Broker are used in the context of forest management, protection, and safety. We have similar cases in all the 3 projects. I won't enter in all the details in all of them, but we want to mention that, for instance, in the case of Minerva, we did not create any new data model because all were reused. But in the case of the indoor environment observer, we added new parameters like the total volatile organic component, the CO2, the CO2 level, or the infrared that are being used to monitor what is happening indoor within the building. For the building data model, we added the people occupancy. And in the case of Nereo, we created new data models, the sea condition and the bike lanes. And for the beach data model, what we did is the same as we did for the building one. So we added the people occupancy to control or to monitor how is the occupancy of the beach. And now we will explain briefly the implementation roadmap that we follow. This is a particular project because we are talking about 3 different projects with different casuistics, but looking all the time for the optimization of the resources and the reusability, because, well, the team implementing the 3 different projects is the same. For sure, we have specialists in the sensors deployment, in the data acquisition, and so on, but the resources were shared. So we had to optimize the, let's say, the time for investigation and for analysis. So the first thing is to analyze the real problems, okay, and to design a high-level solution in order to scope the projects, the 3 of them, because, we need to scope where to deploy the sensors, which are the data that we will take, and which are the expected results. We used Fireware Sandbox for the development and deployment, and Docker to make this deployment independent from the system where it is done later. Then we went to we had to identify which relevant existing data source we could use. With existing, I mean existing sensors in the cities that we could reuse, or open data portals, or any relevant data that the cities could consider relevant, or our experts. Here, the feedback and help of the cities was needed due they had the knowledge about which data or sensors we could reuse, especially in regards of the sensors. Then we went to the data. We already explained that the first thing was the research, and then create new data models and so on. And then we had to, because we had in mind that the technology should be compatible with Context Broker, that everything that we are going to develop is reusable in other projects, and it's open source. So this was done for all the different modules because we had to identify modules, again, to be reused from the repository. And if this is not the case, we have to identify algorithms and other things that we could reuse and are open source. Then we go to the implementation phase, in which we had to develop the specific modules for the different projects, as I was mentioned, the rule engine, that it's common, the smoke detector, or the recommender for Nereo. And for this, we want to remark that apart from a common development in every project that you could see, we had the feedback and the involvement from the cities and from experts provided by the cities in terms of provide that feedback and give us which rules are relevant for them, because one of the challenges that we have here is not just taking the data from the sensors or from the open data portals, but what to do with this data, how we transform this data in information relevant for the city. So this is one of the challenges of these 3 different projects, and for this we have the support, as I was commenting, from the cities, from experts. Again, for the installation, we have the support for the cities. The installation and especially for the sensors was done by specialists. We were supporting this installation, indicating to them how they have to connect the different devices. We were performing different testing in the field. Later, you will see some pictures from the installation. And here it's a remark again, the collaboration that we have from Joaquin, a rural agent expert in firefighting. And in Sevilla, we have the collaboration of Natalia, that is the technician expert in conservation from Diputación de Sevilla. So thanks to them, because they were providing a very useful information. Now, I would like to remark briefly the reusability from two different points of view. So one is if we want to talk about reusability in terms of different projects. I mean, if you want to build a project similar to the ones that we have, you can explore the reusability from the different data models that we build, the different buildings, or if you are talking about fire prevention or forest conservation, you could reuse data model related to fire forest, or the different modules that we build. Okay. We have another way of exploring the reusability, that it's looking into if you want to develop different artifacts, or if you want to explore from the development point of view. You have the Orion LD, you have the sandbox, you have the data models or the data visualization enablers. But if you want to explore from the components point of view, we develop for these projects the rule engine, the connectors for LoRa and HTTP, and the NGSILD context broker data visualization. So these are different views of reuse in the components or the data models that we created for these projects. And now I will show you how we did the deployment and the different devices that we deployed. I won't explain each of the sensors that we have here, but I would like to say that we have in Silvan, we have sensors, these four main sensors, that is the camera, the CO2 sensor, the soil sensor, and the weather station. Each of them has different, or could have different type of connections, the HTTP, LoRa, Modbus, and they are acquired specifically for these projects. They were installed in the field. Later, we will see some pictures. And they allow us to take this information and then to convert this data into information valid for the cities. And the Context Broker is the one that is harmonizing and organizing all this information. For the project Minerva in Sevilla, we had two different sensors: the camera for controlling the forum, and the ambient sensors that it's providing to us a lot of information like the temperature, humidity, illumination, CO2, and other information that it's relevant to monitor the impact that these variables could have in the heritage, in the pictures, in the furniture, in the building in general. Finally, for Nereo, we want to remark that we reuse existing sensors like this temperature and humidity sensor and the weather station, mainly the weather station that was already existing in the city of Benidorm. Now we are pending on the deployment of these beach devices that were acquired, but due some delays due to the COVID situation on the arrival, finally the deploy is not yet ready, but the system is ready to get the data and the algorithms are ready as well. So you will see later that on the demo application that's partially some information is missing, but they will be deployed as soon as possible. Here, I would like to mention the deployment. So this is the deployment procedure in terms of software that you should follow if you want to deploy one of these projects. So it's as easy as install the Git, the Docker, and Docker Compose. So it's mainly the tools that we are using for getting the code and for the deployment. You need to select the deployment solution if you want to deploy local or cloud, or you want to use the sandbox. Then you have to go to GitHub and get the code into your environment. And then you have just to run the Docker Compose file that we created for the project, and once it is done, then you have the project deployed. For sure, you need the sensors in order to connect or to get the data, because having this, you will get data from open data portals and so on that are available. But for creating your own project, you need to configure your sensors and to configure the connectors and so on. But all the information is available on the repository, as well as the installation manual. Here we take some pictures from the installation from Sevilla, from Minerva, Sevilla, and from Ourense. So here you can see on the left side the camera that we install over this door. So this is to control the forum. Then you have this sensor here, that is the other sensor to control all these variables. So here we would like to remark that it was really, really important to create a non-intrusive installation, because you can see that the building is really old, and you cannot go there and create holes in the walls, because, well, it's not allowed. And we had to install something that can be taken out easily and with the less intrusion possible. In Ourense, we didn't have this limitation because it's in the forest, but we had another limitations as we had in Sevilla as well, like the connectivity. Okay, so here we had to find a place in which we can deploy it with warranties. We had to find a tower. Again, thanks in all the 3 projects to the cities because for their contribution on the installation as well. This is where we install the camera, and here you can see the gateway, the power supply for the different sensors, the weather station, and the humidity sensor on these 3. So these are the sensors that are providing the needed information, the needed data to create the let's say the use case, the value of the use case for the cities. Now I will do the demo part. I will swap my screen. One second. Yeah. Okay. So here, so this is the demo of Minerva in Sevilla. Well, this is the live environment. So we have a backup, a video backup, just in case, but we wanted to perform the demo live. So here on the right side, you can see this panel in which we are showing the real-time information about this church. Okay, you can see the occupation, that is 6 from 500. You see the air quality index, that it's taken from outside. So this information is taken from these sensors from the IMET, the Meteorology Spanish agency. We have some indoors conditions, the TVOC, the total volatile organic component, that is calculated directly by the indoor sensors. Then we have the CO2 level, that it's an scale. This scale is calculated from the data provided by the indoor sensor. And here you can see the 3 different, the sensors that we have deployed. So if you click here, you will get some data from the sensor. So the data can be configured. The data that you are showing here can be configured from the configuration panel. Okay, and basically this is let's say the dashboard in terms of what you can see in real time. But for Sevilla, I have to say that for them, what is really important is not just the real time, that it's relevant for them, but the real time is not adding real value to them. Because what they want to monitor is the impact of this conditions into the building, okay, to take preventive actions and so on. So we created 4 different dashboards. One is for the outdoor, and 3 for the indoor. So you can understand easily that one is to provide information on a daily basis. This is monthly. This is grouping the information monthly, and this is yearly. So the point is that the sensors were installed 2-3 weeks ago. So we don't have very much information yet, real information yet, but you can see here some daily information. This is the real information that they want to explode. So you can, you can edit this and customize as you want. So you can add from the configuration new graphics and measures and so on. You can take this data and extract and play with it on an Excel file if you want to create your own dashboard on your own reports and so on. And here you can see the same information but expressed on a monthly basis. So this is so here you can see some filters, and this is mainly common to the 3 different use cases. What is different is the kind of data that we are showing. Okay, that is basically the same information. If we go to configuration, so you can see here the different services that we are getting from Context Broker. So here you can configure the services. These are the different values, the different fields that we are showing on the map that you showed before on this tab. And you can configure new services here and so on. Choose entities, attributes, and you can edit or you can configure your own rules. Okay, so we have here different rules like the illuminance, occupancy, height CO2. So this is about defining the name, taking the service. So the service is the indoor. So I want to explore the CO2 attribute. This is the operator, and this is the threshold. Okay, and this is the you allocating one category, the subcategory, and so on. So this is creating alerts when something is over the threshold. Okay, and you will receive the notifications here. So you can create your own alerts here based on the information that we are gathering. Okay. Well, we have the different alerts aquí, the severity and so on. Okay, so this is the case of Minerva, Sevilla. Now we will see briefly the case of Ourense. So in this case, we deploy the sensors in the forest. So you can see here the forest. We have the legend. This legend has been configured to show in green what is good, let's say. Okay, so if it's red, it means that smoke was detected. This is the, let's say, the confidence of the machine learning algorithm that it's detecting smoke and it's doing this differentiation between the smoke, the clouds, the fog, and so on. So this is the kind of train that we did here with real images and real pictures. This is the dry detected. So another measure that we are taking. And this is the fire weather index. This is representing the risk of having a fire based on the weather conditions analyzed from the data acquisition. This information is taken from the weather index and the soil sensor. This is basically the information that we are showing here. So this will change the color if this is changing color, the smoke detector. So we can go here to detail of the sensor. This is the weather station. So this is basically the dashboard. So if you deploy more sensors, so you will have here more information and you will enrich this information that we have here. We want to say that all this information is performed while it's shown in real time, even if some of the information that we are analyzing is not provided in real time. And let me explain briefly. So we are getting partially information from drones. And so the drone is doing some flights on a weekly basis, on a monthly basis, wherever they can perform the flight. And then we take the images and we process the images. But the information that we are showing is in real time. So if the drone is able to perform flights and to send the information every minute, so we will show the information updated every minute. So it's prepared for this. Well, we can go again to the historical dashboard and we'll see something like similar to the case of Sevilla, but configure and customized for this particular case in order to show the relevant information for Ourense. It's taking some time. Okay, so you have here the summary temperature, the relative humidity. You can here apply another filter. Well, you have different graphics here, the wind speed versus time, CO2, the soil temperature. So it's everything that we can measure, we transform it into information that could be valid for taking some decisions. Okay, this is for Ourense, and now I will show you quickly. So I won't show the dashboard, sorry, for Benidorm because well, it's more or less the same, but with other data. But I will show the application that we develop and we design for Benidorm, that it's focused on the citizens. So this is for providing to the citizens some kind of recommendations for healthy leisure. Okay, so you will see that some of the data is not being taken in real time because of the sensors delay arrival that we have, but it's prepared for getting the information in real time. It's just about deploying the sensor and expose the data. So the first thing is that you can select your preference. So the preferences will be the default preferences will be based on the weather conditions, but you can select your preferences. You can say, okay, I prefer in the same conditions, I prefer to go to the beach rather than bike routes or walking or whatever. So then you save, you go to the first, let's say, to the home page, and then this is the recommendation. So you will see the weather condition, and you will get some kind of percent of recommendation for you to go to the different places depending on the condition and the priorities that you provide to the application. So here the first recommendation is going to the beach, that match more than 80%. Here you can see the condition of the beach. We have two different beaches here. The occupation is not yet providing information because this camera is not yet deployed. You can see the temperature, the water temperature, humidity, speed, air quality index, and so on. You could select another beach if you want. And then you can go to explore the walking routes. Okay, so we implemented here the different walking routes that they have in the city, that Benidorm has in the city. So here we don't have real-time information that we could have the air quality index, for instance, or the occupancy because of the delay of these sensors. But the idea is to show this information here, and finally, well, these are the different routes that you could select to go there. And then finally, we have the bike lane. So the bike lane is the same. So you can access to the different bike lanes that they have in the city, sorry. But you cannot see the occupancy in real time because till now we don't have the real time data, let's say, for this information. But it's prepared. So if you have a city, if you have an API exposing this information, so it's just connect to the application and you will get the information here. So it's as easy as expose the API and consume the information from here. Okay, well, this is basically the recommender that we have for Benidorm. Now I will go back quickly to the presentation. Okay, and then finally we will see some conclusions. So sorry. So in regards of the conclusions, well, the first thing that we want to show you is 4 challenges that we would like to remark. The first one is that you will need specific connectors for the specific sensors that you will deploy. So you need to take into account that if you could have the connectors already deployed, you will save a lot of time, or basically you need to understand that the sensor that you will acquire should be open in order to develop connectors if you don't have them. So this is something that it's relevant. Another thing is the amount of time for the devices, for the sensors as acquisition that we have. So once you select the sensors, you need to take into account the situation. So we know that this particular situation with the COVID, it's something that it's particular, but it's been extended more than expected, and it's impacting in different areas that you cannot imagine that like these sensor arrivals, because some of the components are arriving from Asia, and we have this delay that affected to the timing in the project, to training the modules, because we cannot get the real data and so on. Then you should take into account when designing the use case. This is not about installation of the devices. This is about designing the use case, the limitation that you could have at the time of the installation. In Sevilla, for instance, we cannot install, for instance, a vibration sensor in a wall because it's too intrusive, and we were not able to find any vibration sensors that is not about creating a hole in the wall, and put the sensor there. So, and we cannot do this. So this kind of limitations and related to the connectivity, it's something that you should take into account when you are designing the use case for the project. And then another challenge is to add value to the data that we are getting from sensors or from external sources, because one thing is taking the data. You take the data, you can have a lot of data, but the real value is what are you doing with this data? What are the value that this data is adding to the cities for decision making, or for exploring possibilities, or for reacting in time to a fire or something like that. So this is the kind of things that you should take into account when you are designing the project. This is one of the main challenges that we have. Some general conclusions here. So we would like to remark the flexibility of the platform in terms of highlights for a successful implementation. So this is something that you need to take into account. And in this case, Context Broker is basic for the success of the project because of the flexibility, the reusability of data models and components, again, that can be reused for the core platform. So you have to try to don't reinvent the wheel every time. The support services from the looking from the sandbox to the fireware team. So you need a support team for the success of these kind of projects. And for sure, you need the aid and support from the city officials, providing information, testing, helping with the installation. And without them, you cannot perform this kind of projects because they know the business. And all related to create a modular development, sustainable and scalable solution. It's something that you should take into account for a successful implementation. Last thing is some benefits that we perceive for the cities. That it's now they have a project, they have a decision-making tool to explore the possibilities of a data-driven project and context broker platform. They have a project ready to be extended with full autonomy because everything is open here. they get promotion and visibility at European level, and they get the support from CEF and the ecosystem surrounding Context Broker that it's really valuable. So that's all from my side.
Thank you very much, Sancho. This was really a great presentation and a great demo, in my opinion. And we had a lot of interaction with our audience as well. So I know that Regina was working very hard to answer all these questions. So I suggest I will add her also into the stream, because this concludes actually our presentation part.
Mm-hmm.
And I will quickly, while we're all at screen, I will just put myself as such and look quickly to the questions that still did not have an answer, but maybe we can start with the very first one that comes into my mind, which I believe it was directed to Adam. Yes, absolutely. So I will add Adam right away and put the question on screen. And Adam, this was during your presentation from our audience. So if you'll be kind enough to answer all your experience with that.
Okay, thank you, Erbil. So the implementation that we've used in the highest network is a private Ethereum blockchain. We use Geth to create the smart contracts. And the idea with Highest is that everything is completely self-hosted. There's no requirement to use any third-party services. So the blockchain is Ethereum. There's also another building block that's part of CEF, which is related to blockchain, and we're hoping to begin to align with that as well. So within the blockchain that we have at the moment, we have a number of smart contracts. One of them is for authentication, one of the authentication permissions. One of them is for, sorry, I've gone back. One of them is for data integrity, and we've got a future version coming for patient data. Sorry, I said Geth before for the smart contracts. So we're programming Solidity for the smart contracts and use Geth for actually running the blockchain. Hope that answers the questions.
I think this was pretty okay as an answer. I think all somehow technical questions that were asked were answered as far as I can see. So I suggest we give our audience a couple more minutes to, if there are any other questions that will arise. I will also took the liberty of adding into our chat a satisfaction survey. If you can, if our audience members can take some time to reply to these questions, it will be thoroughly appreciated. It allows us to improve our methods and the way that we reach you out.
Could I approach one of the questions here?
Yes. Which one do you have in mind?
Okay, it was regarding to the data sets that are being used. In our case, this has been one of the biggest problems, obviously based on the associations based on leukemia. One of the biggest problems has been being able to access to data sets that we can use to train. So for the first 2 years, we were lucky enough to have a collaboration with Fabio Scotti from the University of Milano, who had open sourced a small data set for acute lymphoblastic leukemia. And that had been what we focused our work on for quite a while. I dropped the link into the chat earlier. But that data set is very small, and a lot of the other data sets are very, very small as well. So this is one of the problems that we hope the association could help us with, to be able to make partnerships with hospitals, with medical organisations that may be able to give us access to that data. Because although our classifiers that we've been releasing since 2018 work very well in regards to the metrics and also in real world systems, we really can't validate them properly until we're training on hundreds of thousands of images, 20,000, 10,000, 50,000, because we really don't know how it will work in the real world use case. And one example of that is Google, who recently did, they had a classifier that was working perfectly. As soon as they put it into a real world system in a hospital, it was terrible due to the quality of the data sets. So there's a lot of problems with data sets, but this is one of the things that our association is focusing on to try and find, what problems actually come up. And when I talk about real world systems within our association, I don't mean in a hospital. I mean systems that we build that actually utilize these on the highest network that we've built. I also dropped a link to a SARS-CoV-2 project that we've done. We actually have a partnership with Clayman Lancaster from Lancaster University, and they had a collaboration with some hospitals in Sao Paulo, and they built one of the largest open data sets for SARS-CoV-2 CT scans. And again, that data set was literally the foundation of the projects that we worked on last year. So we really rely on the open source data sets, but when you talk about medical technologies, we need to have very, very big data sets, so that's a limitation.
All right. Thank you very, very much for this clarification on your end. I think one of the questions that we somehow answered, but Sancho, feel free to elaborate on this, on how have you solved the power and global communication problem for the sensors?
Yeah. Okay. Well, in Benidorm, we, as I was explaining, we are using already existing sensors, so they were already deployed there. For the new sensor that will be deployed, we will use an existing infrastructure. So we will deploy new sensors over an existing infrastructure. So this problem it's solved. In Ourense, we are using LoRa connection and 4G, a 4G router for the connection to internet and in order to upload the images and the information taken to an FTP server. And for the supply, this is why we select this tower, because we need supply, and we were looking for a place. Well, Fernando was looking for a place in which we could solve this kind of problems initially, because you need to think that this initial project, it's a way of exploring the possibilities, and then at the time to extend the project, probably in some of the places we need to find another possibilities for supply. In the case of Sevilla, we are using LoRa for the devices and internet connection, and their already existing internet connection inside the building. So in Sevilla, we had to perform some connection testing because the width of the walls, so in order to avoid any connection problem.
Thank you very much.
Anyway, I would like to remark that all this information could be found, as well as the links within the documentation that it's already or will be available soon on the repository. So including functional documentation and technical documentation.
Yes, so as just to remark additionally, so in the answers to questions, a lot of the answers, you may also find them in the technical documentation. And as I mentioned in some of these answers, we will also have some kind of storytelling wherein we will really detail step by step what Sancho has mentioned in the webinar, and with even more details, along with the GitHub repository link. So that page will be available. I think, Erbil, maybe we can post it on the Q&A separately so that everybody has this link. So we will post this journey document as well as the links to the GitHub on this page after the webinar. So you can watch out for this in the next coming days.
Absolutely, and I think it might be fair, since we also registered a lot of questions to the event registration page that was made available. I think it will be worthwhile to add all these questions and the different answers that we already provided for everyone's knowledge, also for those who could not be here to watch, and they will also have the access to all the questions that were raised and that was answered. All right, I will quickly check if we have anything else new that just came in. But yes, the last one was on that. I don't see any new questions coming in. And I think we'll give just one extra minute. We're nearing to the allocated time that we were thinking of, to not to go way too deeper. I will just also put on screen just for a second the different links where you can still reach us. They will be copied into the event page, and the different. I will also put these links into the chat. And aside from that, I think we covered all our bases and we extended the program that we had in mind. So I don't see any new questions coming in.
Sorry, just to remark as well, there was a question about other open data portals. They were referring to the European data portal to bus positions in Malaga. So just to let everybody know as well. So in this, in answer to this question, we have also, as part of the CEF Context Broker service, a list of other open data sources that are NGSI LD compliant, along with the matching data model. So you can also find that answer, the link to that in, I guess, Erbil, we will post it as well in the PowerPoint. But I have also answered with the link.
Indeed, we will make sure that these are all documented following the event as well, for those who weren't able to. All right, I think this can be a good time as any to wrap things up. Thank you very much to all of our speakers for this insightful presentation, the representative of the cities, Caroline, Regina, Adam. Thank you very much. We were very happy to be able to show you today the different ways that we've been foreseeing the different activities and the extended support projects, as in contrast and in the highly anticipated way. Thank you very much for your participation, and a big thanks to you, our audience. Follow us on our different channels, and this video and also the slides and also the questions and answers that were provided will be made available on the event registration page. And I think that's it. Wishing you all a very pleasant day coming from sunny Brussels, and stay safe, and see you very soon for a future event on CEF Digital. Bye.